Alright, so these are drone 1 and player rogue drone. So right now I'm just making a script that when you play it, the drone 1 will go up to 6, y equals 6, which is about 600 meters. And yeah, it lands over at 10. Then it goes to 10, which is 1,000 meters. Comes back and lands at the original position. I also wanted it to loop, so there it is looping, and it's going to do this indefinitely in perpetuity. So here's the code for that. If you want to take a look. But yes, I did prompt ChatGPT a few times to get the right code, and yeah. Next, I wanted to be able to give the player rogue drone controls so that when I move it in the path of the drone 1 that's flying autonomously, the autonomous drone will yield and respond to the rogue drone. So, we're building an autonomous system, an 8-lane Z-axis kind of setup, and I want to have a rogue drone that can interfere with the path. So I have some code that I got from chat, and I'm getting this error right here on the bottom: invalid operation exception. You're trying to read input using the Unity engine input class. So what chat is saying is to revert to go to edit project settings player, under other settings, find active input handling. So let's just write both. Let's restart Unity. And there you go, it works. Now I'm gonna see if the rogue drone. Okay, see, that's so cool. Okay, so the rogue drone now yields to me when I go in front of it. Alright, let's keep going. Alright, so the next thing I wanted to do was make this 3D, because 2D, it's all there is to it, really. But I'm gonna show you. If you saw in the beginning, I'm gonna show a clip of what it looks like finished. But basically, there's 8 lanes, and I want to demonstrate all the lanes with the rogue drone, which I should probably add a material to like red or something too. Couldn't find red, so I just went with white. But basically, this guy, drone 2, is going to go from here to about 20 units to the right, north. So this positive z-axis is north. So I'll just show you instead of saying it. Let me just load it up. And I believe north and south lanes are, see right here, the north lane is actually the lowest lane, so if you're going north you're going low. But as you can see here, when I fly this guy in front of him or into his path, he also reacts. It's kind of hard flying from this perspective. See, he stopped. Okay. So this is just demonstrating that the AI works. If you can call it AI, I don't know if you can call it AI, but the script works. And I'm gonna add about, I think, two more autonomous drones. So yeah, let's keep going. All right, so now we got the west, the northeast, and the south. No, the northwest and the southeast, which is this one right here. This one, and it should stop. Honestly, this angle is really hard, but you can take my word for it. It will work if if a collision is detected. The autopilot drone 3 will stop moving. Let's add one more. Alright, one thing I did forget is sorry, I got messed up. But I forgot to add player rogue drone to the rogue drone element, I guess you could say. So that's why when I flew by it, it wasn't reacting. It should react now. And I also added drone car 4, which flies northeast and southwest. So it's over here, as you can see. So let's see if it reacts. That one does. Okay, so drone car 3 is now reacting. And it's really difficult to get like from this angle. I don't even know which. Okay, I don't even know which drone is which, but I'm assuming that it does. I really should add the camera to play a rogue drone so that I can actually fly with them. Yeah. Alright, so I replaced the drone. I made objects for the drone cars. And I tried making like a lane visualization to show like that the drones are traveling at a specific height. I'm trying. I don't. All right. So I think I need to attach the camera to the player drone. Um, and I might need to extend the lanes out a little bit so you can see which lane. But as you can see, I'm interfering with that drone, so it kind of yielded to me. But yeah. All right. So I added the 8-lane demonstrate like visual. So each color difference is a different lane. I also added some landing pads for the drone cars and some buildings to kind of give you a reference for the flight. So let's see now. As you can see, the drones are going over the buildings. So I'm gonna add a chart to show you what these different colors are. But basically, whenever a drone car is flying a certain direction, so for example, if it's going north, it's flying at the lowest altitude lane, which is, I believe, 400, which I believe is this drone car right here. Actually, that's east. That's east to west. But this guy right here, he's flying south and north. I believe the northwest drone is, so see how he's flying at the lowest altitude possible? Just above the buildings. And I believe the north, I forget which one it is, but the northeast drone and the northwest drone are flying at the highest altitude. I believe it's this one. No, it's this one right here. He's flying at the highest altitude. And just imagine that these drones are landing in the same spot but next to each other. That's why they landed on top of one another. But yeah, this would ensure that drones don't crash into each other when whenever a drone car is traveling a certain direction, it enters a specific lane, illustrated by the different colors that you see. And yeah, so whenever it's taking off or landing, the taking off, the ascending and descending drone yields to any drone flying horizontally in the I believe that's the y-axis, I believe. Or no, it depends which direction you're going. But whenever you're in the XY coordinate plane, depending on like what you guys get what I mean. When you're traveling parallel to the ground, you have the right of way. And that's essentially what LorenzOS is kind of solving, is this problem with air traffic. And just imagine these two drones are landing next to each other, not on top of one another. But yeah, that's pretty much it for this demonstration.